Yeah, it's a pleasure being here. I want to speak about ways how we can use natural language processing, machine learning, and visual analytics towards improving information acquisition and processes within companies. I want to start with a short structure of this talk. Basically, I will at first outline some of the challenges, then talk about the technology stack we have been applying in these projects, and then I will show you how we usually use visual analytics to enable people, especially in the management, to better understand what we can do with this technology stack. And then, based on this, I will show you 3 concrete use cases which we have done as parts of InnoSwiss or CTI projects, one on digital asset management, one on company valuations, and one on recruiting, which basically demonstrate how you can use NLP in these settings. And obviously, we will conclude with the conclusions. If we do web intelligence projects, they usually have at least two parts of challenges. The first kind of challenge are technical challenges. We apply statistics, natural language processing, and machine learning to problems that are usually handled by people. And these methods are, in contrast to the people, rather knowledge poor, but they are well predictable and well described. This knowledge poor means basically that if you have, for instance, a machine learning data that is different from the data you used for training, you might get unexpected results. And in addition, we use data that is not always that reliable, for instance, web data, data from social media, etc. On the other hand, we have the economic challenges and domain-specific challenges. We are some kind of enabling sciences. That means we provide methods that can improve productivity, but at the end of the day, we always need the domain experts, the people who work in the domain, to basically have ideas together with us to create business value, to optimize business processes, and to design new products and services. And visual analytics are very useful in helping these people to better understand what they actually can do. In our projects, we usually draw upon a technology stack which we developed together with 2 partner universities in Austria, the Vienna University of Economics and Business and the Modul University Vienna. And it has more or less standard NLP components. We have components in green that are basically concerned with basic text processing and data acquisition. For instance, web crawling, social media crawling, crawling from PDF files. We also do stuff like deep web mirroring, where the data is actually hidden behind databases and where we need to do queries to get to the data. And then we do text processing with this. That means boilerplate removal, where we get the relevant parts of the data. We do part of speech tagging, dependency parsing, and so on, so that we can use more advanced methods on these data. And then we have these building blocks in blue that are basically components for processing the data. Stuff like classification, clustering, named entity recognition, named entity linking, where you locate organization, people, etc. in the data. Also stuff like phrase extraction, where you get significant keywords out of the data, and rather specific stuff like, for instance, privacy-aware knowledge extraction, where we try to extract data in a way that preserves the privacy of the people that might be mentioned in the data. On top of these 3 other modules, one is a module for data enrichment, where we use third-party data that is machine readable, for instance, Wikipedia, that's a linked open data version of Wikipedia, to enrich this data, and visual components that help us and better communicate what we can do with these methods. At the end of the day, what we would do is basically, if we start a project, we would speak to the project partners and ask them to provide us with the data so that we can show them what you can do with very simple methods with this data. This, for instance, is a screenshot from a dashboard we did for an SNF project on media criticism. And what we did here is just that we visualized the search for the term billag. And you can see with associations and phrase detection, you can fully automatically get keywords that are related to the search term. You can generate tag clouds out of it. If you consider sentiment, you know whether the coverage is positive or negative. And with a little bit more advanced methods, you can even create relations between the terms that have been automatically identified within the data. Now you can combine this with stuff like named entity linking. Named entity linking of geographic entities allows you to arrange the data among locations. If you do this with organizations and people, you can see in the data which organizations are listed, which people, how they relate to each other, and whether these relations are perceived in a positive or negative way within the data. You can use clustering to get relevant concepts, and you can do relations between different entities. Okay, how have we used this now in different use cases? And I want to start with the digital asset management use case to show this a little bit. This has been the Imagine project, which we did together with Keystone, which is Switzerland's largest photo agency. And they had a problem with their metadata quality. They have two kinds of images or photos they process. The first one are the photos that are created by their own people. And they are well tagged, they are manually tagged, and there are only 250 of them per day. But then they have a second feed of photos, and they come from third-party agencies, amounting to about 25,000 images per day. And there they have real problems with the metadata quality. Because, for instance, you would have an image with a river, a castle, a little bit of forest, and it would be tagged with dog. The question is, why dog? Answer is very simple, because dog is a very frequently used search term. And these agencies, they want their photos to be found, because this increases the probability of the photo to be bought, and therefore the probability of them to getting money. But obviously that's not good for the customers of Keystone or for Keystone itself. Therefore, they wanted to create a system that automatically extracts metadata related to the photos. And the thing works as following. Every photo or image has basically a mandatory image description that is always provided by their own photographs as well as from third-party institutions. And what we do is that we go in the first step into this text and use named entity linking to automatically identify people, organizations, locations that are mentioned in the photo. For this reason, we know this is Marcel Hirscher, we know the location, we know that this has been a FIS event, and so on. Then we can use linked token data to enrich this information, which allows us to deduce that, for instance, he is somebody who comes from Austria, that he does skiing, that the FIS is a skiing organization, that this location is located in Italy, etc., which allows us to do much, much more interesting searches, because now, for instance, we find this photo even if we are looking for a skier rather than only for the person mentioned in there. In addition, we extract keywords and the corresponding sentiment, and then we take all of this data together and use it to classify the photo according to the IPTC taxonomy, which is a standard taxonomy that is used in the news media business. That's basically what we have been doing in this project. We are currently in the process of deploying this with Keystone's system, and in a short time they will be able to use this and hopefully to improve the quality of the metadata in the process. The second project I want to introduce comes from a completely different domain, and that's company valuation. Here we also use different data sources, and basically web data sources and deep web sources. Let's start with the company, that's Venture Valuation, and what they do is they basically have profiles from different companies in the pharma and biotech domain. And these profiles are basically like information on the company, on the products they have, on the licenses they have, on the IP they have. And this information is used by different pharma companies around the world to decide on acquisitions and mergers they are doing for deciding on license deals. Maintaining this data is very, very resource intensive because they need to do most of this manually. That means they go through the web, take a look whether the information has been changed. If it has been changed, some person actually updates the database. And step one, which we have been doing, is that we automate this by at first detecting whether web pages have been changed. And if these web pages have been changed, we use again named entity linking plus slot filling to extract the updated information. The second thing we wanted to do is to provide additional information on the state of research the pharma companies are currently in. And for this, we wanted to get information on the clinical trials they are currently conducting and on the stage in which these trials are. The good news is there are some databases around the web which have this information. For instance, there's clinicaltrials.gov in the United States, there's a trial database for the European Union, and the World Health Organization has a database that basically spawns all of this information and gets updated around weekly. But the problem is, they do not provide this data in a structured format, but only in a deep web setting. That means there's a database where you can issue search queries for instance, certain symptoms, and then you will get all the trials that are currently running for this. That means what we did here was that at first we asked the World Health Organization whether it would be okay with them if we use deep web crawling to actually analyze the database. We got their okay and permission, and we then created the component that automatically extracts all the information on the trials, plus information in which phase this trial is, whether they are only searching people who are willing in participating, or whether the trial has already been successfully completed, etc. We then extract this data and ground it to the companies, which basically now allows venture valuation to give them much more fine-grained information to decision makers on the stage the companies in regard to their IP, because they know not only the products they are currently selling, but also products that are basically in the pipeline, and also to a certain degree the stage in which these products are. Finally, final use case is in recruiting, again with very similar building blocks, and that is the job cockpit project we have been doing together with Magix. The executive summary of this project is what they are trying to do is to get a search engine for people with certain skills, for potential job candidates, where you can say, for instance, I'm looking for a data scientist or construction engineer who lives in a 15K diameter around Zurich and who has the following specializations. How do they plan to do this? Idea one is that we basically mirror team sites from different companies and then extract from them the information on the skills that are present in the team sites. Very important, only the skills, it's privacy-aware knowledge extraction, not about the names of these people, into a known database. But often these skill descriptions are not very instructive, because for instance, if you have something like project lead, it doesn't give you any idea, okay, because they're project leads in very different areas. Therefore, we contextualize this information with the industry of the company and the products this company is offering. For instance, in this case, we would know that the Sylvia Jaus is a project lead in a company focusing on engineering, planning, and consulting. It means we know approximately the area. All this data is basically stored in anonymized job profiles, and then we use these job profiles together with an ontology which is very comprehensive on different job profiles, the relation between them, skills, educations, to search within this data. That's the first business case, which is already quite interesting. The second one is even maybe more interesting, especially for data scientists, because what we also do is that we track people and how they move across the web. We do this with in an anonymized way. Every person gets an anonymized identifier that you can recompute if you know already the name of the person. And this we can use for predictive analytics. That means the idea is to collect basically the typical careers people have in different industries, which could let you do stuff like, for instance, that you say, okay, I have somebody who has studied engineering at ETH, and he has been in his current company for 1.5 years. Based on typical careers that basically are, I have a study, I go into the first company where I have my first experiences, and after 2 years I change into another one where I get a much better position because they know most of the trouble I had already in the first company. Based on this, we can suggest to a person that, like after 1.5 years, it would be time to apply for a new job because you will get a much more interesting position, better position with another company. We can also do this the other way around. We can tell companies, okay, take a look, you have this person and he or she is very well performing. Based on our statistical assumptions, it's very likely that this person will leave the company within the next year if you do not make the person a better offer. You can also use this in companies to basically take a look at jobs you have and the transition probabilities between these jobs. For instance, you are a Java developer. Then you have a certain probability of being a senior Java developer within a certain time frame. And the senior Java developer may, with another probability, become, for instance, a chief technical officer within the time frame, and so on. And these probabilities can basically be used to help people in much better plan their careers. The final application we had for this one has been in the field of internal applications. You have companies that have to face challenges like digitalization, thank you, and they basically want to give their staff the opportunity to train so that they are fit for the positions and the job skills they will need in like 2 years. And for such companies, what they can do is they can take a look at these typical careers, and based on this say, okay, currently we have people with these skills, but we would need people with another skill set. And what are typical ways to get through this skill set? What are typical educations we need our employees to make? What are typical trainings? That's basically the idea of this project. Okay, what are the conclusions of my talk? First of all, in my point of view, natural language processing, machine learning, mixture learning, analytics, we are like mathematics, we are in a way an enabling technology. And if you want to apply this to a real-world setting, you are faced with at least technical problems or challenges and with economic challenges, which require you to closely collaborate with the people that are in this field to which you want to apply these methods. That's one thing. The second thing, it's also very important that you have a very clear understanding of the data sources you actually want to use, about the problems and strengths they have, and also about the methods and the limitations of the methods you are using. And that's very important to develop this together with the domain experts so that they do not have completely expectations that you can't fulfill. What we always say is that basically, if you have a data source and the human who has unlimited time resources, then you can basically, based on this idea, you can assess whether it's feasible to do a certain task with this data source or not. Because what we get from machine learning, natural language processing, is basically a method that can process data very quickly, like a human would be able to with unlimited time resources. And based on this, we then identify suitable methods which we apply to the projects, which finally lead to very interesting and very different applications. Thanks a lot.
Thank you, Albert. We have a few minutes for questions, if you have any. No questions? I will have one. I was curious to understand how much time did it take to develop one of these projects?
Each of these projects is about 1.5 years. But they are based on components that have been developed like over a time span from about 14 years. And basically the idea is we have these different groups in Vienna, in Chur, and they do, for instance, Horizon 2020 projects, InnoSwiss projects, and based on these projects they improve these components and apply them to different contexts. Yeah.
Here's the next question. Are the components ready to use?
Pardon this again?
Are the components ready to use in projects?
Yeah, ready to use in projects and in different settings, exactly. For instance, named entity linking would be one of these. We started creating named entity linking in a project together with Aurel Füssli, but then we used it in, I think, 10 projects or so in very different
So the
settings.
1.5 years is just the first time development, and then it should be shorter.
Exactly. Then they get basically improved in from project to project, and yeah, used. Yeah.
Question, you have this keyword topic thing, and if I understood correctly, they are defined basically by patterns, rule-based patterns for some of the platforms.
These keywords, they are completely statistically determined. That means this is basically an association algorithm that does this, phrase detection plus keyword detection, in this case.
And the topics on top?
Oh, the topics on top, they are determined by the domain experts. For instance, in this project, we wanted to see media coverage in different media outlets. And therefore, we have here like the media outlets that have been determined by people from the ZHW, Institute of Communication Sciences. And if you then search, for instance, for a keyword within an outlet, you get automatically these associations that are now completely computed by the system. This is basically statistics. It even works with Chinese and with Spanish, etc. And we have done this in these languages as well.
So these are collocations?
Exactly, collocations at the end of the day.
Thank you. One question?
Just a distribution question. Do you keep the components on your premises, or are you delivering the components to the customer?
That depends on the arrangement we have with the customers. Most of our customers, they are not very interested in maintaining these components, therefore we provide them as a web service. But if a customer would insist in having them at his own premise, which would basically mean that it's much harder to update them, because currently if one of the projects updates a component, this gets distributed to all the others. Then it would be possible to find an arrangement where we do this, I guess.
Any other question?
Thank you.
No more? Well, thank you again.
Thank you.